Welcome back. This time we're going to do a visual display of our residual plot. So I will highlight the years, then I'll hold the control key while highlighting the residual values. Now, same as last time, insert scatter chart. Now there's my residuals. I don't want a title. I'm going to shrink the residual chart down a little bit. Typically we display that straight underneath. Now I will add axis titles. So the verticals is residual and the horizontal title is the year. Now let's have a look at these residuals. I think I might format the horizontal axis to start from 1960. Just like the one above, and it finishes at 2030. So that makes it fairly easy to compare these with what's going on above. Now you can see the residuals are actually, they're all fairly small, aren't they? They're all roughly between +2 and -2, when these measurements here are in the hundreds. So these are quite small residuals. That's a good sign. It means that the model is a close match. If the model were perfect, it would match every data point exactly, and every residual would be 0. Now that's never going to happen. So we've got a little bit of positive residuals, a little bit of negative residuals. That's okay. They're fairly random. There is a bit of a bump here. Now, I'm not too sure why there's a bump there in the 1980s. Perhaps for some reason, perhaps there was some reason why the CO2 levels were higher than the growth. You can almost see the little X's slightly bulging above the orange curve there in that region, which is sort of highlighted by the residuals. Maybe there were volcanic eruptions in Hawaii at the time nearby to the observatory, which artificially boosted the CO2 levels around the 1980s. Uh, Not sure. So that's that's just it's a fairly random residual plot, and that's what we're after for a good residual plot. Now, there's two methods of testing the validity of your model. We chose a quadratic model. That was an assumption. We assumed a quadratic model would be a good fit. We've got a very high coefficient of determination. That tends to validate our choice. And we've got small, fairly random residuals, which also validates our choice. So that's um, that's something we could talk about in the evaluation, and that's comforting. Now, that's probably enough for this one. Next time, we're going to talk about uncertainties and how we can deal with that on our graph. Thanks for watching.